Hi friends, welcome to the aeronautical science videos. Now let us see about the aircraft performance, stability and control. To start with the aircraft performance, stability and control, we need to know about the different types of airspeed indicators used in the aircraft cockpit. So now the different types of airspeed indicators are the indicator airspeed, the equivalent airspeed and the true airspeed. These are the three types of airspeed indicators mainly used in the aircraft cockpit. Now let us see what is the difference between these three types of airspeed indicators. Now let us see about the indicator airspeed. The speed indicated by the airspeed indicator in the cockpit, which is based on the pitot static tube attached to the aeroplane. As we all know that the main purpose of the pitot static tube is to measure the dynamic pressure. As we all know that dynamic pressure is nothing but the kinetic energy in the fluid because of its motion. So the kinetic energy formula, as we all know, that of mv squared. So in case of we are dealing with the fluids in motion, we are mentioning here of rho v, we are mentioning here of rho v squared. So the indicator airspeed is proportional to the dynamic pressure, that is of rho v squared. So next let us see about the equivalent airspeed. It is the airspeed which is measured with reference to the sea level density. The equivalent airspeed VE is equal to root of 2W rho naught SCL, where the rho naught which indicates the density at the sea level, where W is the weight of the aircraft and S is the wingspan and CL is nothing but the coefficient of lift. So in the equivalent airspeed, the density remains constant with the increasing, even in the increasing altitude also. So next let us see about the true airspeed. It is the actual speed of the aircraft, the airspeed which is measured with respect to the standard atmospheric conditions, where the true airspeed is equal to V is equal to root 2W rho S CL, where rho is nothing but the density at a particular height h. So in the true airspeed, we all know that with the change in or difference in altitude, there is obviously the change in density also. So when the altitude increases, the density is will be decreasing. The decrease in density is nothing but due to the decreases in pressure. So when the altitude increases, the pressure decreases, which leads to the decrease in density. So the true airspeed is measurement of the velocity of the aircraft at a particular height with the given exact density of that particular height. Okay, so now let us see the velocity and density relation with respect to the altitude. So velocity density relation is nothing but the dynamic pressure of rho naught VE squared is equal to of rho V squared, where V is equal to VE by equivalent velocity by rho naught squared, where rho by rho naught is nothing but the relative density sigma. So from this we can able to find the true velocity, where V is equal to VE by root sigma. So the final note is that when the aircraft is flying with the increase in altitude, the density decreases, so the velocity of the aircraft increases. So from the in the upcoming lectures, let us see about the gliding flight, the climbing flight, the level coordinated turn, the pull-up maneuver and the pull-down maneuver, the range endurance, the accelerated flight, which is the takeoff and landing performance of the aircraft, and the airplane stability and control on the upcoming lectures. So thank you for watching the aeronautical science videos. Thank you.